So I'm Nick Bolton, I'm the CEO of Ordnance Survey. Ordnance Survey is the national mapping agency of Great Britain. I've been asked to talk about spatial computing and what it means for national mapping agencies. But before I move on and talk about spatial computing, I wanted to define, first of all, really, what a modern national mapping agency is, because the task has materially changed over the past 10 to 15, if not 20 years. So really talking about where is national mapping today. First of those is clearly for pretty much the first 200 years of our life, we just produced maps. We had a pure cartographic output. It was 1 to 1250, 1 to 10 thou, 1 to 25 thou, and 1 to 50 thou. And that's what we produced. That's very different than what we produce today. But we now also serve enormous wads of data in a wide variety of applications. Also back then, we had a very narrow sourcing model. You know, we sourced data largely from our own field surveyors, whereas today we source from a wide variety of different sources, from EO to aerial to drone to open source to underground data. It's about how do you integrate all of those data streams and yet still assure the quality that everybody expects of a national mapping agency. It's also fair to say that when we had that narrow sourcing model, we could also run a vertically integrated value chain. You know, we did it all. You know, genuinely, we had the boots on the ground, and we actually printed the maps. You know, we had a printing press, and we put them in the envelopes that sent them out to the customers. But that just isn't the way that this works now. We now have this intermediated, wonderful multi-actor ecosystem. We have technology providers. We have other data providers collaborate with us. That's a very different role that we then need to play as a national mapping agency. And it's lastly to say that the reason why we're doing all of this new stuff is because now there is actually a much wider application of geospatial than there ever has been before. We've moved from a limited series of use cases now to a much larger mass series of use cases, and I don't see that going backwards anytime soon. The value is not in the data, but on the insights that they enable. The data in itself has no intrinsic value. It has its value in its extrinsic expression. In other words, we need to get that data applied to domains in order to liberate all of those applications. But I thought it was worth laying out, really, that the idea that we go from making sure that we are the national positioning authority, we need to know where stuff is. We then have to go through a process of sourcing, and as I've said, that now comes in a multi-int way. And then actually that then means because we've got these multiple sources, the refinement piece then needs to do a better job of integrating those data sets using increasing degrees of ML and AI, using data science, geocoding, making sure we can move between all of those networks, and then fundamentally assure the quality of that data. We then need to serve that out, and we do that in a number of different ways, and then importantly, we make sure that it actually does get applied, because it's in the application where the value of those insights are. You know, for me, spatial computing is really about that blending of those two worlds. So that's true for autonomous vehicles. But it also applies in precision agriculture, how we guide the farmer, the tractor driver, to make sure they plow the field in increasingly straight lines. So that blending of the world is spatial computing. And it's been enabled because actually now storage, so data storage, compute, the ability to do analysis on stuff, and then the presentation of that, you know, three fundamental building blocks of computing systems, can now actually be located anywhere. We need systems that can understand us and our surroundings. And if mapping's not central to that, I don't know really what is. We are the custodians of the modern national map. But the task of the national map today is to serve a very different set of use cases, to serve a very different set of audiences. We need to be able to have that national map communicate its capability to other machines. So we need machine-to-machine interfaces. We need data structures that are visible and easy to understand and probably discoverable through agentic AI interfaces. The second thing is that in lots of ways, the data that we provide, that national map, is the base plate upon which other people can clip their data into, both from a public sector perspective as well as in a private sector perspective. The great thing about a map is it can provide that foundational layer, that very thin layer of fabric upon which you can slot a whole series of other capabilities. The National Mapping Agency, I feel, is that base plate upon which all of those other actors can clip their capability. we also are facilitators of an ecosystem. In other words, the National Mapping Agency, more than anybody else, can actually convene gatherings like this. And we've got a right and a need to make sure that software providers are talking to data providers, that private industry is talking to the public sector, that we're facilitating and active in that innovation role. If we do that, that will deliver for a spatial computing future for the country, and ultimately what is our task as a National Mapping Agency, which is to facilitate building a better Britain for Britons to lead better lives. I was going to close on a personal story. So in 1995, I joined a business that absolutely sat at that interface between the real world and the digital world, a motion capture business. And we worked at that point on films like Titanic and Star Wars, and that was a very, very small niche. What I think the opportunity is for us here as an industry and as a National Mapping Agency is to take that out, that spatial computing capability, to a much broader audience. And if that doesn't get us fired up, I don't know what will. Thank you.